Today's problem is called matrix spiral copy. I'm also digging my look today. It's a very interesting but tricky problem. Giving a 2D array matrix, input matrix of integers, create a function spiral copy that copies input matrix values into a 1D array in a spiral order clockwise. Your function then should return that array. Analyze the time and space complexities of your solution. So for example, if we have an input matrix, which is basically an array of arrays, the output should be a flat array containing all the numbers, followed in a order of a spiral clockwise. And we have an illustration down here, which will help you better understand what a clockwise spiral order looks like. So if this is a matrix, by looking at the arrows, it goes like this. So top row, right column, bottom row, left column, then repeat. We can figure out the time complexity and auxiliary space before we even solve the problem. Because each value has to be visited in order to make a copy, they both will be O of n times m, where n is the number of rows and m is the number of columns. The function implementation is rather straightforward. We can first initiate the top row, right column, bottom row, and left column. Let's call the arrays inside the matrix index points. The top row is the first index point of the matrix. The right column is at the position of the last index of the index point. Because each index point has the same length, we can just use the length of the first index point. The bottom row is the last index point. And the left column is at the position of the first index of the index point. The while loop represents the spiral cycles. Whenever the spiral completes one cycle clockwise, we move the rows and columns inwards by manipulating the indices until they meet each other. The while loop will only run when it meets both of these conditions. So if either of these conditions breaks, such as the left column going over the right column, or the top row going below the bottom row, the while loop stops. And for each iteration of the row or column, we push each number into a new array. We increment the top row to move it down, decrement the right column to move it to the left, decrement the bottom row to move it up, and increment the left column to move it to the right. At the end, the return array will be our one-dimensional copy of the matrix. The tricky part of this problem is that order matters a lot. Not only it illustrates the spiral clockwise by going in the order of top, right, bottom, left, we also need to avoid pushing duplicates. Within the cycle, where we position the increments and decrements along with these if statements, help us avoid pushing duplicates when the left column goes over to the right or when the top row goes below the bottom row. Let's take this one, for example, where only one row is in the matrix. Remember that the increments and the decrements happen inside the while loop, but will not stop the while loop until the first iteration is done. So without these conditional statements, before exiting the while loop, there could be a chance where top is greater than bottom or left is greater than right, resulting in pushing a duplicate. So if we run the function, you can see instead of 1, 2, it's 1, 2, 1. Same thing happens if the matrix only has one column. Now, instead of 1, 2, 3, it's 1, 2, 3, 2. 2 is a duplicate here. But with these conditional statements, the inside for loops will not be hit. So if we run the function, everything passes.